Hello, so today I'm going to explain the mechanism and mechanistic reasoning of the electrophilic aromatic substitution reaction of nitration of benzene. So we are given a reaction here where the nitrobenzene react with concentration HNO3 under the condition of 50 until 55 degrees Celsius with the catalyst H2SO4 and forming benzene derivative which is M-dinitrobenzene plus water. The first mechanism that we need to apply is the formation of electrophile. Before that, we need to know from this reactant who is the electrophile and the nucleophile. What's the electrophile and nucleophile? So, concentration HNO3 will become the electrophile because it is more acidic and it contains H plus here, while the nucleophile is nitrobenzene because nitrobenzene contains benzene ring it has a rich electron site. First step is the formation of electrophile. You only need to remember here the formation of electrophile will form two different electronegativity of oxygen ion, which is partially positive oxygen ion and partially negative oxygen ion. How? The HNO3 will attack the H2SO4 so that the electrophile can be formed. We can see here this by drawing it in terms of lone pair, where we show the lone pair on the oxygen. We can see how it forms a new bond of hydrogen and partially different negativity of oxygen from this attack. So, one lone pair of HNO3 will attack the one hydrogen atom on H2SO4, and one of the lone pair of oxygen will form partially positive oxygen ion. And also, the bond here will break to become partially negative oxygen ion on the H2SO4, and the attack of HNO3 with H2SO4 will become partially positive oxygen ion because the H binds with the oxygen atom here by forming these two different negativity of oxygen ions. Electrophile is formed, which is NO2 plus, and then water as well as HSO4 ions. Second, the formation of uranium ion. This is a slow formation. To write the formation of uranium ion, we need to have 3 uranium ions. We need to draw 3 uranium ions. Right, we need to draw 3 uranium ions, and we need to write slow here, and then direction of benzene with the electrophile. That's the main point to write this reaction on the second step. Electrophile will bind to this site because we can see from here the given product is where the electrophile, which is the NO2, will bind at the carbon here. So we just need to react it with the carbon here. Don't forget it has hidden hydrogen here. Write it like this, and then under the slow reaction to form 3 different uranium ions. The first one is when the NO2 bonds here, there will be no carbon-carbon double bond here. Okay, so the plus ion, the ion will form here because the bond here already taken by the H and NO2. Alright, and then the bond, the uranium ions, we know it is a intermediate ion, so the double bond of the benzene ring will move. It will always move and change its place. The second uranium ions is where the charged ion will go from here because the bond will move in front. So there is no bond, carbon double bond here, thus the ion are formed here. By the way, the NO2 are stayed. It doesn't move, only the carbon double bond will move. If the carbon double bond moves, the ion also moves. That's why it is called intermediate. The third uranium ions is where the ion will move back here and formed here. So the carbon double bond will move here and form a ion here. So we can see there is a changing of different places of the ion. Third is the deprotonation of uranium ions. From this step, we need to know that one uranium ions are taken and it will react with the partially negative oxygen ion from the H2SO4 to reform back the H2SO4 and to form the complete or stable aromatic compound. So the partially negative oxygen ion from the H2SO4 will bind with the H atom from the uranium ions and form or reform H2SO4, and then the uranium ion will lose H atom and it will form back the carbon-carbon double bond here, and then we already got our benzene derivative. This is the benzene derivative, which is reformation of the carbon-carbon double bond and also the reformation of H2SO4. So basically, in conclusion or in short, for the formation of electrophile, firstly, it's the most important things here is we need to form the electrophile. The tips here is electrophile we need to always remember, electrophile is always a acidic compound, carbocation, cations or Lewis acids. So from here, this is cations. We know that the electrophile here is the cation, which is NO2+. So in the formation of electrophile, we need to form the two different electronegativity of oxygen ion, which is from the concentration of HNO3 and the concentration of H2SO4. As the HNO3 is more acidic than the concentration H2SO4, it will become the partially positive oxygen ions. Thus, the H2SO4 will become partially negative oxygen ion and form electrophile, which is NO2+, water, and HSO4+. For the formation of uranium ions, we will need to have three types of uranium ions with different places of the charge. Don't forget the slow reaction here and how it attacks with the electrophile, how the benzene ring attacks the electrophile. As the uranium is the intermediate ions, we need to stabilize it to form the benzene derivative in stable aromatic compounds and reform back the H2SO4. By taking one of the uranium ions, we need to attack it with the partially negative oxygen from the H2SO4 so that the H2SO4 will reform when one atom from the uranium ion reacts with the partially negative oxygen ion from the H2SO4 and reform back the H2SO4, and then we got the aromatic stable compound, which it is called a benzene derivative. I think that's all from me. Thank you.